Welcome to this webinar. So let me share my screen quickly. Let me share just a minute. Okay, yeah. So this webinar is basically for Docker and Kubernetes. And here you will get more insight about what is Docker, what is Kubernetes, what is the use of containerization in our application deployment, right? So let me introduce myself. My name is Raman Sharma, and I'm a certified Kubernetes application developer and administrator. Okay, so I have around 18 plus years of experience in IT industry. So I'm delivering the IT professional courses on the corporate level, on the public batches level. It's almost more than 18 plus years. Okay, so today the motive of this particular webinar is to discuss about containerization. So as you know, these days the buzzword is containerization. Everyone is looking for Docker and Kubernetes, and Docker and Kubernetes, they are basically. So now what is containerization means? Now, as you know, whenever we are doing an application deployment, whether you are having web application, whether you are having microservices, whether you are having database applications, any type of application, right? Whenever you are having an application, then you need to deploy somewhere. So let me quickly, open some tool like MS Paint is my favorite one. Okay. So here, consider you have to deploy an application. So this is your server, and your development team is saying, can you deploy this? There is a development team, right? And what they are saying, can you deploy this application on this server? So now this is your virtual machine, right? I hope everyone is aware of virtual machine. So virtual machine is a virtual in nature. RAM, CPU, hard disk, everything is virtual. Networking, everything is virtual, right? But it has a complete operating system. Whenever you start a virtual machine, it takes time. It takes maybe 5 minutes, sometimes 10 minutes. Why it is taking time? Because as soon as you start your virtual machine, it is basically started with loading the image. So every virtual machine is having a guest operating system. Okay, so it takes time. So if I just draw some diagram for the virtual machine, so it will be the architecture point of view. It will be something like this. This is your physical server, for example. Okay, so this is your physical server. Physical server means any server, like your laptop is also a physical machine, right? So server, when it is a server, then it is a physical server. Server means very hi-fi configuration like 120 GB RAM, right? 10 terabyte or maybe petabyte hard disk, right? 8 CPU, 10 CPU, I don't know, right? So physical server. So on physical server, we are having something called infrastructure, right? So we are having the infrastructure. Infrastructure is nothing but it is your hardware, like CPU, RAM for that physical server. So the virtual machines which you are creating on it on top of your physical server, so that depends upon the infrastructure of your physical server. So if you are able to create 5 virtual machines, not 10, because your physical infrastructure does not support that. Okay, so your physical infrastructure should support that the capacity. Okay, on top of that, we are having something called hypervisor. What is hypervisor? Hypervisor means those who are from the virtualization background, they know much better than me. But hypervisor is something which is basically used to manage the virtualization. So if you are having your virtual machine, then someone has to manage it, right? Because virtual machines are virtual. So hypervisor like VMware is the most commonly used hypervisor. Then on top of that, right? On top of that, we are having something called guest operating system. Okay, we are having guest operating system. This guest operating system is the operating system of your virtual machine. If you are creating multiple virtual machines, then there will be multiple guest operating system. Okay, there will be multiple guest operating system, right? And on top of this, guest operating system, we are having our binaries. Binaries are nothing but the runtimes. What are the runtimes? Runtimes are like if you are installing Java application, then Java runtime, OpenJDK. If you are using .NET based application, then .NET runtime. Right? So these are called binaries or libraries that is to be installed. So binaries or libraries, right? And here also we are having the binaries or libraries. Then on top of that, we are having the applications. So our applications are running here. Okay. So some applications are running on virtual machine 1, some applications are running on virtual machine 2, and some applications are running on virtual machine 3. Okay. This particular part, this part, this part. So this particular portion is called virtual machine. This is called virtual machine, right? So it means if you are not using the containerization, you are using this approach. Single physical server, if you are installing the application, that is very, very old approach. I think no one is using that. If you are working in company, right? So you are using the virtual machine for your development, testing, production environment. So that's why I'm discussing that. So this guest operating system, this guest operating system is a complete operating system. What is the meaning of complete operating system? It is with the kernel. Every operating system is having a kernel, whether it is Windows, whether it's Linux. So here we are discussing Linux-based Docker and Kubernetes. Okay, that part. Windows part we are not discussing. So considering these three are the operating system and these three are the complete operating system, means with the kernel. How this works? Actually, whenever there is a request comes from the application, because these applications are running in a virtual environment, so they need to request for the RAM, CPU, or other hardware resources to the kernel. So once the request goes to the kernel, then it goes to the hypervisor and hypervisor to infrastructure. Okay, so the flow is like that. When the application is running, it needs some memory, CPU, or other hardware devices. So that request will go to the guest operating system and guest operating system to hypervisor, hypervisor to infrastructure. And in the reverse way, the response will be sent to the application. So whenever you are starting your virtual machine, right? So it first loads your guest operating system. Then it loads binaries or libraries. After that, it loads the application. So this is the way how virtual machine starts. That is why it takes time, right? This approach is good. This approach is far, far better than the approach which we were using a single physical server. For each application, we were creating we were having multiple physical server. So that approach was, as compared to this, it was worst, right? This approach was very good. Now, again, the betterment comes as compared to the virtualization. Now, if we talk about the applications which are getting developed in the modern era, these are the microservice applications. Microservices, web application, even though you are using the web application, you are using different design patterns, right? So if we talk about the microservice approach, first of all, when you are developing any microservice, you are basically concentrating on certain points. Microservice is developed by the development team. As a DevOps engineer, we are not creating these microservices. This is developed by the development team. So they need to take care of few things. That whenever a microservice they are creating, it should use that much memory which is required. Means, for example, if I create a service, it needs 10 MB of memory, right? So they need to tell you that this application maximum use 10 MB of memory, not more than that. So microservice, as the name suggests, micro means very small. Services, microservice means very small application. Let me give you one example. For example, you are having a banking application. In this banking application, you have some modules like internet module. You are having, say, uh, internet module and deposit service, and you are having withdraw service. You are having something called, say, customer care. So these are the 4 modules into your banking service. So now what I'm doing, I'm taking this internet service as a separate deployment, deposit as a separate deployment, withdraw as a separate deployment, and customer care as a separate deployment. So these are 4 different applications. Internet banking is a different application. Deposit is a different application. Withdraw is a different application. Customer care is a different application. But these are getting invoked into your banking application. Okay? So these are getting invoked inside your banking application. This is a loosely coupled design, right? In this loosely coupled design, what we are doing, we are creating all the applications as a separate application. These are deployed separately. And if these applications are getting deployed separately, then how I can invoke? Because this is the banking application which needs these functionalities, internet banking or deposit, withdraw, all this, right? So banking service will call these applications, okay, or invoke. We use a word invoke these services. So all these are microservices because internet banking does not know what is to be done with the deposit service. Maybe banking service know how to integrate internet banking and the deposit service, but internet banking service does not know. So it means this service is deployed separately, and we are using something called here containerization. Okay, so here what we are doing, we are using the containerization. So these are deployed as a container. This is deployed as a container. This is also deployed as container. All get deployed as container. Now, sometimes a question arises, why not as a virtual machine? On a single virtual machine, I will create these 4 applications. So the reason is because when we talk about DevOps, so in DevOps, there are in a day, you are doing multiple implementations. Okay, that is a possibility. If you see the Amazon, they are releasing many times in a day, thousands of times in a day for their release. So if we use the virtual machine approach, that will never work. We need which is immediately get created, immediately get replaced with the new version of the application. In that case, we need to use containerization. So I hope this concept is clear, right? Now, next is what is the architecture of this containerization? So if we talk about the containerization, I'm talking about Docker. Docker is a containerization tool. There are other containerization tools are available, but Docker is number 1 in the market. So that's why and this webinar is for Docker and Kubernetes discussion only, right? So here, what we are having a physical server. Again, physical server, or and on top of that, we are having our infrastructure. Right? On top of this infrastructure, we are having means it may be actually it is these days on virtual machine. On top of virtual machine, we are creating containers. Okay, so there will be hypervisor. On hypervisor, there is a virtual machine, and on virtual machine, containers will be created. So I'm not going into that deep level of detail. I'm simply saying there will be a host machine. Okay, and on top of this host machine, and this host machine is a complete operating system with kernel. On top of this host machine, something called Docker engine. Docker engine is to be installed. It is a software which we need to install, which is installed as a service, and it will install something called Docker daemon, Docker D, which is running as a service, okay, in the background. You can install Docker on Windows machine, Mac operating system, Linux machine, wherever you want. Now, on top of that, we are running our binaries. There is no guest operating system. Okay, so for example, you want to run something related to uh, OpenJDK, something related to MySQL. So there is a separate Docker images are available in the form of binaries. So we will use the respective binary which is required for the containers. And on top of that, we are having the applications or application. Actually, one container, most of the time we are having one application. Excuse me. And this portion, this is called container, where my application is running. Right? So now this is running as a container. Now there is no guest operating system. When the application needs some memory or CPU, to whom it will request? It will request to the Docker engine. Okay. And Docker engine will take forward that request to the host machine kernel. Now consider you are running some application which is Ubuntu based and your kernel host operating system is Red Hat. Will this Red Hat based system support Ubuntu related activities? Because Ubuntu is it's a Linux, Red Hat is also a Linux, but their kernel definition could be different, right? So the question is that whether this Ubuntu related application which is running as a container will be supported by this Red Hat, because everything kernel related activity will be shared with this host machine kernel. So the answer is yes. So host machine, right? Your host machine operating system, whether it is Red Hat, whether it is Windows also. So all the modern operating system, they have updated their kernel in such a way that they can support the containerization. It means Ubuntu container can run on top of Red Hat, or CentOS based container can run on top of Ubuntu operating system. Even your Linux containers can run on top of Windows operating system. Okay, but you need to have the latest version, right? So this is a container. Now containers are considered as very lightweight. Okay, so these are considered as lightweight. What is the meaning of lightweight? So lightweight means they are using something called Docker image. So Docker image is lightweight because it is without kernel. So containers are running with the Docker image, and the Docker image is without kernel. Means you are running your application without kernel. And kernel related activity, you will get it from the host machine kernel. Okay. So this way we are basically using our containerization. Let us see this practically also. So I'm taking one machine. So I have created one machine on my AWS. Now I will say login with the root user. So let me change the host name as Docker01, right? And if I say bash, now what I'm saying, let me install Docker. How to install Docker on, so this is Ubuntu machine, any version you can take, apt update and apt install docker.io. Okay, so I'm installing the Docker. So Docker is getting installed. Okay, so it is taking little bit time. So So the Docker is installed on my machine. How do you know Docker is installed? You can run a command docker ---- version. So Docker 20.10.21. This version is installed. Docker is developed in a programming language Go. Okay. So now it is installed as a service. So I can say systemctl status and Docker. So you can see it is running as a service behind the scene. Right. Now, if I say I want to download an image, so basically what happens there is, if I go to Docker Hub, which is hub.docker.com, so this is a official website from the Docker. Okay, Docker official website. Here, what you can do, you can search the images. For example, you want to search the Ubuntu image. You can download this Ubuntu image. It is saying if you want to use this Docker Ubuntu image, then you need to run this command. Let us copy this command and run it here. Docker pull Ubuntu. Now what it is doing? It is downloading that Ubuntu image, Ubuntu Docker image from the Docker Hub. Now if I say Docker images, so I can see this image is downloaded. Excuse me, guys. So here you can see this is Ubuntu image. Currently, it is a latest tag. There are different tags are there. You can use 18.04, 20.04. There are many tags are available. So I'm saying I'm using the latest one. This is image ID, which is unique for each image. 3 weeks ago, it is created by Docker officials, and this is the size. See, the Ubuntu image is 77 MB only. Why it is so? Because it is without kernel. If it is with kernel, then it will be 4 GB, 5 GB. The ISO image which you see, right? That is 5 GB, 4 GB, or maybe more than that sometimes. So because it is having the kernel plus some extra software get installed. So whenever a Docker image is created, then you are basically having only those files or software inside it which are required, not unnecessarily software. Okay, so that is why this is very lightweight. Now, if you need to create a container, so you can say Docker and container run -id, and the name of the container, I will say web container. I'm doing a port forwarding. Port 80 of my host machine is mapped to port 80 of my container, and I'm using a image. So let us take some image like Nginx is one of the image which runs on port number 80. I'm running this. So what it is doing, it is downloading Nginx image, and I'm doing a port forwarding so that I can access this application at port number 80, right? So now if I go and take my Docker 0 public IP address, okay, and if I go here and if I enter, I must get Nginx. Come on. Yes. So see, okay, so I'm having this Nginx. Uh, my page is here, right? So like that, there are many applications, right, which you can run as a container. So this I'm using it a predefined Docker image. You can create your own Docker image also, right? You can deploy your application code, which your development team has given to you. You can run it as a container. So I hope container idea is little bit, it is clear to all of you. Right? So containerization is a software deployment process that bundles application code with all the files and library needs to run on any infrastructure. Traditionally, to run the application on your computer, you had to install version that match your machine's operating system. Docker. So this is the logo of the Docker. So it's a software platform that allows you to build, test, and deploy the application quickly. See, when my container get created, immediately when you start your virtual machine, 5 minutes, 10 minutes, it's immediately. The reason, because in the DevOps, the applications are getting processed or replaced, updated very frequently. Docker packages softwares are the standardized units called the containers that have everything the software needs to run, including libraries, tools, code, and runtime, right? That is what we have seen. This is a real-time architecture of the Docker. You have the client machine who is executing the command like Docker build, Docker pull. So we are not in this 1 hour, we are not discussing all the commands, right? We have only discussed this container run command, but there are pull command also we have discussed, right? So these two, but there are many commands. So client is running that command, means the person or the developer who is executing this command from his machine, and he's connecting to this particular Docker host machine. What is Docker host machine? Where Docker daemon is running. In Docker daemon, we are having Docker images. We are having Docker containers, right? Containers refers to the images, but from where we have downloaded the images? From Docker Hub. But Docker Hub is not only the platform where we can download the images. There are many platforms are available. Like we are having Azure Container Registry, that is on the Azure. We have ECR, which is Elastic Container Registry on AWS. You can also create within your organization some registry server, which is called private registry. Okay, so you download the images from your private registry or your global registry to your Docker host machine, and then you can run your containers. The atomic unit of Kubernetes for the Docker is the container. Now, the question is, okay, my container is running fine. Everything is fine in the application. My client is happy. They are accessing the application. Everything is happy here. Suddenly one day application is down. Okay. If the application is down, client is screaming on us. And what he is saying, hey, you told that it will be 24/7. Yesterday it was a critical day for us. We need that application, but application was down. You say, oh, it should be run. Hey, operation team, you did not monitor that. Yeah, I monitored, but I did not realize. Okay, let me start this container again. So manual work will not acceptable in the DevOps world. In DevOps world, you are not going to use any manual work. Everything is automatic. That is why container orchestration comes into the picture. Okay, you cannot rely on the human being, right? If you are relying on human being, it means chances of error is more. So you cannot rely on human being for the orchestration in DevOps. You need to make the process automatic. If your process is automatic, then your customer will not complain. He will say, "Oh, application was, I think, not down. It's always up." How it is possible? It is possible by using container orchestration. There are many tools are available for container orchestration, but the one which is very popular, these are Docker Swarm, which is mainly used for Docker containers only, and there is Kubernetes. So Kubernetes is much better. Lot of features it has as compared to Docker Swarm. So better to go with the Kubernetes instead of Docker Swarm, because that create your application, manage your application, manage the replication, manage the orchestration of your containers. Okay, so Docker is specific platform for building the containers, including Docker engine, container runtime, whereas container orchestration is a broader term referring to the automation of any container lifecycle. So Kubernetes, it's a open source container orchestration system for automating deployment, scaling, management, originally designed. So it is basically Kubernetes is a product of Google. So they have developed it, but after that they have contributed to the CNCF, which is Cloud Native Computing Foundation, which is an open source maintaining the containerized software. So when we talk about, so let's not talk about Docker Swarm. Let's talk about the Kubernetes. So in Kubernetes, for container orchestration, actually, mostly it works on the cluster only. So in container orchestration, we are having our master node. On master node, we are having master node component. This is also known as control plane. This is also known as control plane, which has API server, scheduler, etcd, and the controller manager. So what is master server role? Whenever any request comes, okay, so the request will first come to this master node. Okay, so if you want to create pod, what is pod? Pod is the basic unit of Kubernetes. Within the pod, your containers are running. If any request comes which need to create a container or pod, then it will be created with the help of the master node. So there is a API server which is running as a front end. It accepts all the requests. So the request will go to API server. Then from API server to etcd. etcd is the storage which stores the cluster information in key value pair in the encrypted way. So entire cluster information, how many worker nodes. What is worker node? Where your containers are running, your applications are running, those are called the worker node. And it is maintained by master node. Scheduler will decide where a pod will be created. Will it be created on worker node 1 or worker node 2 or worker node 3? Controller manager, it will running some infinite loop to check the desired state of your resources is equal to current state or not. For example, there is a replication controller. The replication controller will make sure that the number of replicas is equals to the current number of replicas, means current state. For example, if you say the number of replicas should be three pods, similar pods should be always up and running. And how many are currently running? So that is the current state. So whether the current state is equals to replicated state or not, that is the purpose of the replication controller. Next is on worker node, you are having your pod running. There is a Docker. You need to install Docker, right? Because we are talking about Kubernetes with Docker. You have the kubelet. Kubelet is a agent on the agent machines or worker nodes, which is basically obeying the order of the API server. So API server says, can you create a pod with this specification? And kubelet is doing that work. And it needs to maintain that. It needs to maintain that specification, pod specification, which is sent by the API server. Kubeproxy, it manages the network policies, right? So now next is why Kubernetes. I will give you one example, okay? So that will be better. So I already have a Kubernetes cluster. So I'm creating a deployment, okay? So you can create the deployment by using command or by using manifest file, which is called the YAML file. So I'm creating a deployment kubectl and I will say create deployment, and the name of the deployment I will say you can give any name. I will say first I will set the image. I'm saying it is running with the Nginx image. Okay, and it is having the deployment name, which is Nginx deploy, right? And what else? Replicas 3. Okay, so I'm creating a deployment. Okay, already exist. Let me delete existing deployment. kubectl delete deploy hyphen all. So I'm deleting the existing deployments. That was for the previous batch. Now I'm creating a new deployment. Deployment get created. So if I say kubectl get deploy, so you can see there is a deployment get created with 3 replicas. Now if I say kubectl and get all, so you can see that there is a deployment. Because of this deployment, let me delete these services which are not required. So I will say kubectl delete and service, which is hello world 2 service and my service. Now let me run again kubectl get all. So you can see that there are some there is a deployment get created, right? And kubectl delete -fhpa.yaml. Okay, right. So here now it's more clean. So here I have deployment which is running with 3 replicas, and it has created a replica set and the pods. Now, if I delete any of this pod, and this pod is basically with the help of this pod, I'm accessing my application. So if I say, if I delete a pod, so I'm deleting this pod, for example, which is this one, 58 second ago it got created. If I say kubectl and delete pod and the pod name, okay, my client will not be impacted because other 2 pods are running. But if you see, a new pod immediately get created. This is the work which replication controller manager's part is doing. So there is a replica set, and that replica set, that is a separate topic for replica set. So there is a replica set, and replica set is basically doing this activity. So this is the replica set down here, you can see. Right. So my application is always up and running, right? So other thing is that, so that probably, in this webinar I cannot cover. There is something, called security, okay? Because it's a big topic. If I try to show you in the practical, it takes time, right? So I'll just explain you that theoretically. For example, you are a user, right? And you want to use this Kubernetes cluster, but whether you are the authenticated user or not. So if you are not an authenticated user, you cannot use it, right? If you are not a authenticated user, you cannot use it. So Kubernetes provides the security a very high level. Means if you are not the authenticated users, you cannot access the Kubernetes cluster. It creates something called role-based access control. Okay, role-based access control, where every user should be connected with some key, which is public and private keys, and that should include, or in that request, it should include the certificate authority token value, which is basically certificate authority keys, sorry. Okay, so that key values should be embedded into that request. Then Kubernetes will accept that request. Similar way, if we talk about the network policies, so Kubernetes can provide the network policy level security as well. So for example, you are saying a particular application should not be accessible some other pods. Okay, so basic unit of the Kubernetes is pod. Okay, for example, you are having a database application and you are saying only my web application can access this database, no one else can access this database. So that level of network policies you can define, where you can define the ingress and egress rules. Ingress indicates inbound rule, egress indicates outbound rules. Okay. So that level of security you can provide. Security is the top concern of enterprise running Kubernetes, especially as containerized applications become more mainstream. Kubernetes provides several security features out of the box: role-based access control, network policies, and network policies, container image signing. Right, enterprise can also use the third-party security solution to enhance the Kubernetes. So you can use the third-party solutions also for your Kubernetes security. Right, hybrid multi-cloud. An enterprise continue to adopt the cloud-native technology. They are increasingly hybrid multi-cloud environments to meet their Kubernetes. So now you can see that if I go to AWS, so there is a EKS, right? Elastic Kubernetes Service. So you can create your cluster here directly. Okay, you can create your cluster directly here. Means if you are creating your cluster within your own organization, within on your premises, then that cluster is to be managed by you. Containers, not containers, the servers, right? How the servers patching, everything which is related to that infrastructure is managed by you. But if you create it on AWS, Azure, it is the responsibility of that particular cloud service provider. Okay, maybe you want to keep something on your cloud, something on your on your on premises. You can set up a communication between, set up a connection between them. Okay, so that is called the hybrid model, right? But if you want to set up everything on the AWS, that you can do with the these AWS like EKS service or EKS service, etc. So this is called the multi-cloud environment. So almost all the clouds, those like we have Google Cloud. So Google is the inventor of this Kubernetes. So Google provides Google Kubernetes engine. AWS provides EKS, which is Elastic Kubernetes Service, and Azure provides AKS, which is the Azure Kubernetes Service. Now, what is the future? Future of processing the Docker and Kubernetes. Future is very bright. If you think next 5 to 10 years, is there any competition for the Docker and Kubernetes? I don't think so. Okay, because this is totally dominating the containerization world. Docker, if you are going into the infrastructure or DevOps, if you are planning to make your career as a DevOps engineer, then Docker and Kubernetes is must. Okay, without Docker and Kubernetes, you cannot think that DevOps is a complete. So I would say it's a major component of a CI/CD pipeline. Right? So increase the adoption. Both Docker and Kubernetes are likely to see increase the adoption in the future as more organizations move towards the containerization and cloud native architectures. This will drive the innovation and improvement in both technologies and leading to better performance, scalability, and security. Easier integration. As the containerization becomes more mainstream, we may see the easier integration between Docker and Kubernetes. So 99%, wherever you see Docker as a containerization tool, you will see Kubernetes as a orchestration tool. Okay, so integration is very easy. So this will simplify the process of deploying the containerized application, making it easier for the organization to adopt cloud native architecture. Enhance the security. We have discussed that security is the key concern of the organization and running the containerized applications. So we can expect to see continued improvement in the security, both Docker and Kubernetes side. This may include the enhancement of the role-based access network policy, container image signing, as well as development for the new security solution. All right, let me see if there is any question. So, okay. So, right, probably I don't see the questions. So, I would say that means if you are making your career as a DevOps engineer, or if you are already in the DevOps world and you are new to this Docker and Kubernetes, or you want to know much about the Docker and Kubernetes, so this is a required technology for the DevOps. For Docker, we are having a certification which is called DCA, Docker Certified Associate. For Kubernetes, we are having certain certificates like CKAD, Certified Kubernetes Application Developer, CKA, Certified Kubernetes Application Administrator, CKS, certified Kubernetes security. And there are many actually, but these three certificates are, these three certificates are important to which basically indicates that you are very comfortable in the Kubernetes. Okay, so application developer is the first step, you can say, to learn more about the Kubernetes, where you will see that how the pods get created, what is deployment, replica set, services, right, role-based access. So administrative, where you actually role-based access is completely covered in the CKA, where you are having the more administrative related tasks like what is the role based access, how to provide the network policies, right? So if you once you are familiar with the CKAD, then it will be easy for you to understand the other set of topics which are related to CK or CKS. Right. So I think I'm done. So let me just see. What is the difference between deploying on the host or and container? So if you are deploying the application on host machine, right? So you are using if you are deploying it on the host machine, right? You are using the host operating system, right? Completely. But your application, when it is deployed as a container, it's a separate unit of the deployment, which can be managed by the Kubernetes, which is running as a container, right? So that unit, which is the container unit, it is having the its own IP address, its own set of properties. Okay, just it. Docker Swarm, Kubernetes, which one is efficient? Kubernetes. Because Kubernetes has a lot of features. If you have very simple, straightforward application, then you can go with the Docker Swarm. Otherwise, Kubernetes is the one. What is the main win using Kubernetes as compared to Docker? Because Kubernetes is providing you the container orchestration, lot of features like config map, security with the secrets, right? Role based access. So these things we are basically using in the Kubernetes, not in the Docker Swarm. Any other question, guys? Okay, I think that's it, right? So I hope you guys understand the purpose of Docker and Kubernetes, right? Thank you very much for joining this webinar. Myself, Raman Sharma, I'm signing off. Thank you.